Let me, I'm sharing the screen. You guys able to see my screen, right? Okay. Okay. So I have already covered the two topics. Okay. So today I'm going to start the hive. Okay. So just take a little background of the last topic so we can revise it. Okay. And it's a quick recap. Okay. So we started from the big data concepts, right? Anyone has any question can ask me. No one has, then I can start. Okay. So big data concepts, we learn about how many types of data types are there, right? Structured data and semi-structured, unstructured data. We have seen the definitions of the what is a big data, right? Big data is a data which is very, very huge amount of data. And there are the four characteristics of the four V's are there. Okay. The volume, velocity, variety, right? So these are the characteristics of the big data: volume, variety, different sources. The data is coming from the different sources, right? Audio, video, images, right? So different types of data is coming. That is a variety. And velocity is there. The velocity of the data is coming with the fast speed. Okay, so that is the velocity. And the one more characteristic is the veracity. So veracity is a data truthfulness. The data should be truthful. Okay, so if I say the data is a null data, missing data, so that data is no value, right? Because I cannot do the data analytics. So first of all, why we are learning big data, right? We say we are learning data engineering, data science, right? So this big data tools are basically giving the data analytics. Okay. So even though we can do the data analytics, right? We can do some programming languages are there, right? Java, Python, right? But we cannot do data analytics with the large amount of data, right? So that's a Hadoop is providing. That's the tool, traditional tool. Like if I talk about like file system, right? If I store the data in the file system in the form of CSV, JSON, XML, okay, or SQL databases, if I talk about any SQL databases, so they are not horizontal scalable. Anybody is not listening. Okay. So if I talk about the SQL databases and NoSQL, so the alternate came for this, right? If we want horizontal, these are the vertical scalable. The vertical scalability is the when you are increasing RAM and disk, hard disk, right? CPUs, right? It's a some certain limit is there, certain limit. Beyond that limit, you cannot expand. Okay. So that's a called vertical scalability. So we need a horizontal scalability. Why? Because today, if my data is 10 GB or 100 GB or 1 TB, I want to get the data tomorrow 100 TB. So my cluster should be scalable. So horizontal scalability is the main factor, right? And we need some tool which can handle this horizontal scalability. So we know, right, horizontal scalability is there in the NoSQL databases. We have heard about there are many different NoSQL databases or different type of category of the NoSQL are there. Like JSON document oriented NoSQL is there. So Elasticsearch is there. Mongo is there. Okay. And there is a GraphDB is there. So GraphDB is the new 4J, right? That is a one example of GraphDB. And column oriented databases are there. So there are the different NoSQL databases categories are there. Okay. And another one is the horizontal scalability can be provided by the Hadoop. So Hadoop is a set of tools are there. Hadoop is a framework. Hadoop is a framework which is providing the horizontal scalability. And if I say I want to do the large data analytics, so we use. So here is Hadoop is providing a two core component. What are those two core components? So one is HDFS, Hadoop Distributed File System, and the second one is MapReduce. Okay. So nowadays MapReduce we are not using because MapReduce is productivity is not high there because we are writing a lengthy Java code and it's a completely Java based, right? So people who are not good with the Java, they cannot write the MapReduce code. So nowadays it is like now Spark is alternate, yeah, right? So Spark is a processing engine. So same like a MapReduce is a processing engine. same Spark is a processing engine which replaced MapReduce now. Okay, because Spark is 100 times faster than MapReduce. Okay, faster than MapReduce in memory because it is processing data in memory. So memory configuration should be high for the Spark job. Okay, and MapReduce is only for batch processing. It is only batch. It's only for batch processing, like historical data processing. But Spark is not only batch; it can do real-time processing also. So it is good fit for both batch and real-time both. Okay, and other component HDFS, this is the storage component. So the condition for the Hadoop is if your data in Hadoop distributed file system, then only you can do the analytics. Okay, so that's a tight coupling was there, right? In the MapReduce, the another tight coupling is when your data is there in Hadoop distributed file system, then only you can do the analytics. But Spark, it's not like that. Spark can run in the standalone, okay, without Hadoop, standalone, okay, and using the yarn also it can run, okay, based on Hadoop file system, HDFS, and another one is a Mesos server is there, okay. So Spark is giving, and even the Kubernetes nowadays the containers coming in the market, so container based Spark can run also, right? Kubernetes, right? So we can Kubernetes cluster, we can also run the Spark, right? So these are the containers are very lightweight and it is easy to install and configure, and then we can run our job. So it is quickly we can install and configure, right? Using the containers.
Sir,
right?
I have one question on that.
Hmm.
Standalone in the sense like we have a Databricks on Azure. It is standalone, sir, on that
So
Databricks.
Databricks is the platform, right? Same like Hadoop is not a plate. Hadoop is running on some, okay, either you need some operating system, right? Guest operating system like Ubuntu, you installed Hadoop, or you are using Hadoop in the EMR, okay? So Spark is also provided in the EMR, right? So and Databricks also. So Databricks is the Spark like a platform, right? We can use the Spark, but if I want to use other component of Hadoop, I cannot use, right? Because it's providing only Spark on Databricks, okay? But if I want to use my own cluster, right, like a Hadoop, Kafka, HBase, Hive, Scoop, all the Hadoop ecosystem component, so either I should use the cloud-based tools are there, like one is the EMR is there, okay? If I say EMR is in AWS, so that is giving complete Hadoop Spark infrastructure cluster is providing. EMR is in AWS. If I say HD Insight is there, HD Insight is in the Azure. Okay, the same thing. It's just a name. It's a difference of the name. And if I say in the GCP is a data proc. Okay, in GCP. Okay, so these are the ready-made clusters, right? You don't need to install even any single thing. You will just set up the cluster of EMR, SD Insight, data proc. You will get the Hadoop, Spark, whatever Hadoop component. You will get all the. You have to choose in the beginning what you want to install in your cluster. Okay, and everything will be provided by the cloud provider. But in this case, right, when I'm installing my own, right, in Ubuntu, so I have to install my own, like everything I have to install, like Hadoop I need to install, Hive I need to install, Scoop I need to install, HBase I need to install, Spark I need to install, Python I need to install, everything I have to prepare my own. Okay.
Sir,
And
yeah,
Databricks
during
is
the
providing only Spark, right? Databricks is
yeah,
providing the Spark based cluster. Mm.
I got it, sir. I got it. But the problem is that during the interview time, they asked me which cluster are you using. If I go for standalone, then how could I define that one? What is a standalone on in that particular scenario?
See, standalone is nothing like even in the Ubuntu, you can say standalone, right? Like if you're not using the Hadoop distributed file system, that is standalone. Standalone means client mode. Okay. When you are saying like, oh, you don't have any Hadoop distributed file system, definitely it will be standalone only, right? It will be using your S3 file system, or it will be using your Ubuntu file system, right? When you are reading data. So for the small data, definitely you can go for standalone, but standalone is not good for large amount of data. Definitely, see, Hadoop is the framework which is providing distributed processing, right? You cannot get that distributed processing in the standalone, right? Locally, correct? How, so any framework is needed, right? So Hadoop is that framework, right? Which can provide you distributed and multi like a faster way the processing, right? Okay. So Spark has both the options. Either you can go for client or cluster mode. So cluster mode you go, then you can use the yarn cluster mode, right? You can define your cluster mode type yarn. So it will be reading data from the Hadoop files. So Spark you can configure. It depends on your requirement. You can change your input data, right? Where the input data is coming. If your input data is coming from the local file system, you can use standalone. If your input data is coming from the yarn Hadoop, right? So then you can change your cluster manager. You can change your cluster manager yarn type, right? And cluster mode you can define yarn type, correct? Okay. So depending on the requirement, Spark is, that is the reason Spark, I'm saying Spark has the flexibility. That flexibility was not there in the MapReduce. MapReduce is tightly coupled. When I showed you the running a job in the MapReduce, you've seen that we have to copy our input file in Hadoop file system, right? Without copying Hadoop file system, your input file, you cannot process the data. So the mandatory thing is there, right? We have to process the data in Hadoop file system. And for Hadoop file system, if you want to have a data, so definitely you have to use some ingestion tool, right? Scoop is an ingestion tool, right? To bring the data from RDMS, any RDMS database, Oracle, MySQL, SQL Server. Okay. So definitely the data cannot be produced, right? In Hadoop distributed file system, large amount of data, or some streaming data you can use like a Flume. Flume is another tool, right? So Flume is another tool which is providing, right, streaming data, like you can ingest the data. I will show the Flume examples, right? But nowadays, nobody is using Flume and Scoop, right? Because already the Spark is the alternate. Spark is not only ingestion tool, it is not only ingestion, it is ingestion and analytics both. Because when you want to do analytics, definitely you will read the data first, right? Without reading data, you cannot start analytics, right? So you have to create data structures in the Spark. So there are the data structures is there, RDD is there, data frame is there, data set is there. So in this data structures, you have to bring the data, right? Suppose I'm reading a CSV file. So this CSV file, when you read, it will become a data frame directly because it's a schema based data, right? When I say JSON data, it becomes data frame. Okay. Automatically it becomes, you don't need to make it. You can read as a RDD also, but you have to use different way. You have to read. So entire data of the CSV file will come in a single column if you read as a RDD. So that is more complex to process, transform. Because if you are reading data and it is properly column oriented manner, which is more easy to perform transformation, data frame or RDD? Definitely data frame, because RDD is a row oriented. It is processing the data, transforming the data, all the same transformation. If I talk about the transformation in RDD and data frame, both are same. If you say map is there, transformation, flat map is there, filter is there, join is there, right? We can join the RDD, group by key, reduce by key, all the same transformations are there. But complexity is more there in the RDD because RDD is doing the transformation row by row and data frame is doing column by column. So generally, when we have the data of the column oriented type, right, or schema based data, we go for data frame. Okay, JSON data, XML data, Parquet, ORC, Avro. So 99% data is coming as a data frame only. Only the data which is not coming as a data frame, that is a text data, text file data. Like if I say the data which is not having any schema. Okay, so this is see, I'm not going in the Spark because right now our target is to cover our Hadoop component. Okay, so Spark will come, we will go in deeper like Spark, right? There are the Spark is having a lot of depth is there, right? Because Spark is not just processing data, it is bringing the data from the different sources, right? It could be a Mongo, Cassandra, Elasticsearch, Hive, MySQL, okay, or any like if I can say the Snowflake, right? And I can say S3, anywhere you can integrate, or even reporting tools you can also integrate with the Spark. Okay. Okay, so what I was talking about, the component in the Hadoop, right? The two core component like Hadoop distributed file system and the MapReduce. Okay. And Spark is basically the extension. Basically, nowadays nobody is using the MapReduce because Spark is providing a more faster computing, and Spark is providing all the module in a single, like it's a unified language, right? Basically, if I say Spark is providing a Spark core module, Spark SQL module is basically the batch processing. Spark SQL is a batch processing. Okay. And if I say Spark streaming, that is a real-time streaming data, right? So Kafka we can use, right? Kafka we can use, Socket we can use, even the file streaming is also there. Okay. So different ways we can read the data as a streaming data. So generally the Spark SQL we say it's like when we getting a data as we are getting a data as a data frame. Okay. And the streaming is like two types of streamings. We will go in deeper later. There's a D stream is there. That is called discrete stream. And discrete stream is basically nothing but a sequence of RDD. Sequence of RDD. Okay. So manipulation of the stream also difficult in the RDDs. So better we go for the structured streaming. So structured streaming is a advanced way of handling the streaming data, and that is basically the sequence of data frame. So when the RDDs or data frame is coming in a very quick manner and the sequence order, right? So that is called streaming. Okay. So when I talk about what other Hadoop ecosystem components are there, like Hive is there, right? So Hive is a part of Hadoop ecosystem. Okay. And Hive is a SQL data warehouse tool. Okay. So we know, right, there are many other SQL data warehouse tool in the market, and some cloud provider also providing the data warehouse tool, right? Redshift is provided by the Redshift. So Redshift is provided by AWS. So Redshift is petabyte of data. It can scale and it can process, and like we can do analytics on the Redshift, right? Through Redshift, like we have the Redshift spectrum is there to read the data from the S3 and create a tables in the Redshift table. Okay, then we can do. Okay, that is AWS part. Okay, and if I compare like a Snowflake also, nowadays Snowflake is demanding and getting a more popular, right? Nowadays Snowflake is a cloud SQL data warehouse tool, and cloud SQL data warehouse tool, it is using storage on any cloud. On any cloud means like you can choose your own choice of the cloud, whether AWS, Azure, or GCP. You can choose the cloud. So it doesn't have its own storage. It is providing computation on the data, and it is doesn't have its own storage. It is using storage of any particular cloud. Okay, so there are some pros and cons are there, which data warehouse tool is like better, or like here is a Redshift. If I say it is a proprietary tool, so it is cloud agnostic, right? We cannot use anywhere else. But Snowflake is the advantage is it's independent of the cloud, right? Anywhere we can use it. But Hive is a dependency of the Hadoop. Without Hadoop file system, without Hadoop, you cannot use the Hive without Hadoop. Okay. So there is a dependency of the Hadoop ecosystem component, like dependency on the Hadoop file system. So you cannot use anywhere else, right? You can use within an ecosystem you can use. Okay. Okay. So now next is some Hadoop commands I will talk about. Okay. So I talked about last Hadoop commands. Those are very important commands, right? Generally, when we are dealing with the Hadoop file system, we have to copy the file, or right, we are renaming file, deleting file, right? So there are around 30, 40 commands are there. Okay. So some of the commands which are very important, like put command is there, copy from local command is there. Okay. Append to file is there. Copy from local is there. That is the same put command, copy from local. And there is a get command, which is a reverse of the put command. Okay. So if you want to get the file from Hadoop file system to your local, we can use get or copy to local. Okay, copy to local. So I will show you the list, right? It's a big list is there, and we need to do practice of this all Hadoop command. So if you do simply, okay, first thing is like if you have installed Hadoop, you can follow the steps. I will just show you because I will not install from the scratch. Okay, so I'm just going to show you Hadoop installation on Ubuntu. So you can follow the steps and install Ubuntu Hadoop on the Ubuntu. Okay. So here, this particular link is I have tried 100 times. Okay, this is only this one you don't do. Don't create user, just directly follow the steps except this step. Okay, don't create user, install in directly your own user in Ubuntu. Like my own user is, if I show you in the terminal, this is my user, like Arvind. Okay, so in this user, you install Hadoop. Okay, so you follow these steps and you will get, once your Hadoop is installed, this is a manual way we are doing. Okay, and whenever you start your Ubuntu, every time you have to start -all.sh for starting the Hadoop services. Okay, automatically the Hadoop services will not start because this is manual installation you did. Okay, and if you want to verify your all Hadoop services are running or not, the JPS command you can see. So I already started. That is the reason you are able to see name node, data node, and secondary name node. These are the three services are the storage service, the part of the HDFS, and the node manager and resource manager is the part of the MapReduce processing service. Okay. So these 5 services are keep running. It means your Hadoop is running successfully. Okay, so now you want to check the Hadoop file system directory, and it's a virtual directory. You cannot go inside the Hadoop file system. You have to give the entire path of your Hadoop file system. So generally we use the Linux command. So we have to use the prefix Hadoop fs -ls. And then after any command you want to use of the Hadoop command. So first we check how many commands are there. Okay, just I do Hadoop fs. If I do Hadoop fs, you can see these are the total number of commands. Okay, so these commands maybe 20, 30, whatever commands. So these are the commands you have to use. Okay, so these commands, purpose of these commands, some are the informative commands, just giving you the some information about the Hadoop file system. Okay, and like if I say this count command, so count command is just giving you the number of directories and total size. Okay, so those kind of information you are getting. Okay, but some commands are like changing the group. If you want to change the group of your like there is a permissions are there, right? User, group, and others, right? If you want to change the permissions, right? Chmod command is there. If you want to change the honor, is the chown command is there. Okay, cat command is a basic command, right, to see the content of any file. Okay, if you want to create a directory, right, so mkdir command is there. Okay, so I'm not showing all the commands, just I'm going to show you just few commands. So Hadoop fs mkdir, suppose I'm going to create one directory. Okay, so this is I'm creating a directory on the Hadoop root directory. So root is slash. Okay, so when I want to see this directory is created or not, so I will see Hadoop fs -ls slash. So when I do this, so I will see this directory will be created here. Okay, if you see the date and time, everything, and if you see when this directory is created, so who is the user creating this directory? My username. And who is this is the default group is given, but I can change this user and group, because this is like I can use the ch group or chown or chmod I can use. If I see the permission of the command, okay, if I see ls -slash, if I do, so I'm able to see some of the directories are having this permission. So I go particular. So nothing is there. Okay, so I want to copy some file. Suppose I'm here and I want to copy some file to the Hadoop file system. Okay, so Hadoop fs -put. Okay, and then I will say my file, and then I will give the directory where I want to copy. Okay, so this is the directory path I'm giving. So I'm copying the file. Okay, so I'm copying the file there. I copy. If I want to see the content of the file, so I have to give a complete path. So April 6th and slash I say test.txt. So I can see the content of this file. Okay, this is the content of this file. If I want to create a multiple directory together, so there is a -p option is there. So if I say April 6th slash test1 slash test2, if you want to create a multiple nested directories, so generally if you don't use the -p option, it will not allow to create, but if you use -p, it will create a nested directories in a one single command you can create. Okay, if you want to copy again the same file, what will happen? You will get the error, right? Like you are not able to write the file because the file is already exist. Okay, it will give you the error. But still you want to override it. You think, okay, your file is the latest file in your local file system, but still you want to override the file. So -f, you can forcefully override. Okay. So these are the command. Some more commands like append to file. If you have a two files and you want to merge it in the local file system and write to the Hadoop file system. Okay, so append to file, suppose test.txt and test.txt. Two times I want to merge the content and I want to write to the Hadoop file system. So I want to create a name, some new name I'm giving, test1.txt. Okay, so then I can check the content again, same way, cat command, April 6th, and then I will give the test1.txt. So these are the simple command. Just you can do practice. I have already published this command. So just find the complete list of command, and then you can start doing practice each and every single command. Okay. Then you will get what is the use of head command, help command. Help command is giving the information about the command. So suppose I want to check the help of put command. So it will be telling me what are the parameters I can use, right? -f is override the destination if the file already exists. Okay. So these are related to Hadoop commands. Okay. So when we are learning the Hadoop distributed file system, so we should be, first of all, know all these commands and some admin commands also there. Some few commands are the admin commands. So we should know there is a one command is the hdfs safe mode dfs admin -safe mode status. So get is telling me the safe mode is off. So what is the safe mode? Generally, whenever you starting a cluster, when you are starting the start-all.sh, so initially it will come in the safe mode on. And whenever the safe mode is on, you cannot run any command. You cannot run mkdir, put command, anything you cannot do because it takes 13-second time to come out from the safe mode because it is preparing the FS image copy, right? Suppose your data, we already know, right? Name node and data node, right? These are the core component, okay? And when I say name node is containing the metadata. So name node is a master node. It's a master node of your Hadoop cluster, and it contains metadata, which is data about your data nodes. Okay. So it keeps all the information about your all data nodes. Okay. And data node is basically a slave node. Okay. So one name node is there, so multiple data nodes can be there. But in Hadoop 2.x and 3.x architecture, there multiple name node concept has come. Why? Because one name node cannot handle the some set of data nodes. So for high availability, they have given multi name node concept. So that is called standby name node. So one passive name node will be there, which is parallel to the active name node. So whenever active name node down, your passive name node will become active. Okay. So that is in 2.x and 3.x, the Hadoop, they provided this standby name node concept. So data node is a slave node and contains actual data, okay, which contains the actual data. And the secondary name node is a backup, okay. So before Hadoop 1.x, generally the secondary name node is used, right? Because we say Hadoop is a single point of failure, right? When the name node is down, your entire cluster is down because all the metadata is present in the name node. If name node is down, entire cluster is down. Entire cluster is down. You cannot access anything. So the solution is for this, you cannot access anything without name node. Okay. So there is a solution is given secondary name node. Secondary name node is basically backup node.
Pasta.
Okay, so secondary name node is a backup node and which is containing same metadata which is there in the name node. So any point of time, right, if fail, So it starts. So, but problem with the secondary node, it takes 30-minute time. So any point of time, name node down, name node is down, it takes 30-minute time to start up secondary name node, 30-minute time. So we are delaying the 30-minute time request. So the other alternate is now in 2.x and 3.x is there, standby name node. So standby name node is a passive name node, but it will become active. It will become active when active name node is down. Active name node is down. Okay, and it takes 1 minute time. It takes 1 minute time to start up. And there is a one general node is there. There is a one general node which is syncing metadata, between active and this passive name. Okay. So this is just a fact, right? Because I'm not saying you have to get the information, because this is all admin part, right? Okay. But this is for information purpose, right? How this synchronization happen, right? Between the Hadoop, this nodes, right? In the Hadoop cluster. Okay. For high availability, right? So high availability, right? It could be a possible case, right? My data node is down. See, my name node is down. So I have an alternate is this. If data node is down, so I have the backup copy is there, right? I have a replication is there, replication factor, right? So replication factor is suppose 3 is there. So 3 replicas, it will be copying 3 blocks on 3 different nodes. So any point of time, somebody is reading data from data node, and that point of time, if data node goes down, okay, then this name node will identify, because name node is sending a one heartbeat signal, because it's a master slave architecture. Okay, so this name node is sending heartbeat signal every 10th of second. Okay, heartbeat signal. Okay, if that particular data node, okay, data node is not responding, acknowledgement is not giving. Okay, so in that case, name node will find the same block of copy in the other data node and assign to the client. Then client will start directly communicating with that data node. So this is the way of how the data node is down. So we have all this reliability is there in the Hadoop cluster. Okay, because Hadoop cluster is not a single node, it's a multiple nodes are there, right? So we are providing high availability, reliability. So these factors matters, right? Okay, so when we come to the MapReduce, okay, so we have seen so far, this is all HDFS related concept, right? So when we come to the MapReduce, we have resource manager and node manager. Okay, so here again the master slave architecture. So master slave is, right, resource manager is a master which is allocating tasks to node manager. Okay, so earlier in Hadoop 1.x, it was a resource manager was the job tracker and node manager was a task tracker. Actually, the name was changed in the 2.x architecture, okay, and 3. Architecture. So it is allocating tasks to the node manager and allocating the resources also. What type of resources it is allocating to resources? See, for any node manager needs some resources. Okay, like I say, CPU resources is there, memory is there, right? So if I'm doing any task, node manager has some like it has to complete the task, so it needs some resources. So it will resource manager knows like how much CPUs, memory, and disk, all those resources called containers. These are called containers in the 2.x architecture, YARN architecture. We call it YARN architecture. Okay, yet another resource negotiator. So in YARN architecture, these resources are given by the resource manager. So here is also resource manager is communicating to the node manager, and node manager is communicating to the, sorry, not node manager, application manager. So application manager in between the resource manager and node manager. So this application manager is delegating requests to the node manager, and node manager has application master, and application master is allocating containers. I'm talking about containers means the CPU, memory, and disk, right? So this all given by application master to the node manager to perform the task. Okay, to node manager to perform task. Okay, so this is just theoretical part. I'm not going in much depth deeper, but if you go through somewhere else, you will easily understand how this architecture, because sometimes people ask internal how it is happening, right? We should clearly know, right, how the internal architecture is behaving, right? And node manager is which is performing the task, okay. So if this node manager down, who will be taking care of? Resource manager will be taking care of, because it's a master, right? So if any point of time any node manager is down, then resource manager will allocating the another node manager. So here in the Hadoop, this cluster, so every data node is there. The one node manager is also there. So node manager and data node both are on the same machine. Okay, because wherever the data is there, node manager will be performing the task, and resource manager can be on another machine. Okay, and one is the name node machine, that is also separate machine, right? Okay, so this is the architecture. Suppose I have a 10 node cluster. I say I'm processing the data. Sometimes question comes, right, if how much data is can process by your cluster, right? So what is the capability of your cluster? So if I'm assuming it like every node, I have the capacity of 2 TB disk. Okay, every node is 2 TB disk. Okay, and I say 64 GB RAM. Okay, so I will say the total capacity will become 20 TB and 640 GB RAM. Okay, so that will be your cluster capacity, right? So whenever the data comes, right, then it will be processed in a distributed manner. So that's the thing is done by the MapReduce. Okay, so MapReduce is again like providing a concept of map and reduce function. Okay, map function and reduce function. But before doing the reduce function, there is a one more phase is there in between map and reduce. There is a shuffle and sort. Okay, shuffle and sort. Okay. So MapReduce is basically used for the computation, right? Like any computation I want to do with my MapReduce program, like word count. Taking the example of this file, if I'm giving to my MapReduce program will do the word count of each word, how many times is there, frequency of the word count. Okay, or any type of task you can get it done. But the map task is very simple architecture. Like when you say map task, so map is basically splitting data into multiple mapper machines, multiple mapper machines, and all mapper machines running parallelly. Mapper machine is processing data parallel. So that is the reason like faster way of computation is done, right? The mapper is like basically processing parallelly, and the shuffle and sort phase is basically shuffling the data from the different mapper machine and bring together. Okay, so shuffle, and after that sorting by key. Okay, so shuffling is the phase which is bringing data together for the same key. So when I do the word count, I definitely need the same key together, right? So different mappers will be bringing from different mappers, we bring the data together at one machine. So that is basically shuffling, and then done sorting on the key. So when the sorting is on the key is there, right? So I can arrange in the sorted order. Okay, so that is the thing is done by the shuffle sort. But this is not our responsibility. It is done by the MapReduce. And last is the reduce phase. Reduce is basically combining the data. It is aggregating the data, aggregating the result, aggregating count result. Okay, for same key, and get final word count. Get final word count and write the data, to file. Okay, output file. Okay, The only thing is like when I'm writing a MapReduce program, I have to write a one driver class. Okay, one mapper class, I have to write mapper class, one reducer class. So I have to write a lot of effort to write these classes, right? Okay. And it is completely batch processing. Okay. So there are many more concept is there in MapReduce. There is a partitioner concept is there, right? Partitioner is there, partitioner is there, combiner is there, and different types of join is there, map side join. So I'm saying like nobody will ask you these questions, but if your knowledge is there, so if you are learning any Hadoop ecosystem component, you can know, right, how it is internally working. Okay, how it is internally working. So you should know the MapReduce concept, just not for writing code, just for your understanding about the MapReduce. It is useful for you to understand like how other ecosystem component like Hive is there, Scoop is there, HBase is there, Plume is there, right? So how these component will be generating the MapReduce on your behalf. Okay. Okay, so now when we come to Hive, okay, so other ecosystem component is a Hive. Okay, so Hive, we know it's a very popular and very it's as a data warehouse tool is used, right, in the pipelines when we are talking about the ETL pipelines. So Hive is not a storage. Hive is providing a SQL interface to query the data. The underlying storage for the Hive is HDFs. So storage underlying storage is HDFS for Hive. Okay, same thing, underlying storage is HDFS. Okay, same thing you can understand. Okay, any SQL database, can you say SQL database is a storage tool? SQL database is not a storage. SQL database is providing a query interface for the data is stored on file system as .dbc file. So that file is a compressed file. You cannot read the data directly from the file. That is the reason you need some SQL interface, like you use MySQL, Oracle, and SQL. Different vendors are there, right? So many vendors. Postgres is there, right? DB2 is there, right? So these are, but they are following the same terminologies, right? They have the driver classes there, right? Suppose you are connecting any SQL database, you can connect with any programming language. You can connect with the Python, you can connect Java, you can connect with the .NET, right? Every programming language has its own syntax, and they are providing a different ways are there. Like, okay, JDBC driver is there, ODBC driver is there. So these are the different types is there. In the Hive also, so Hive is also providing a JDBC connection is there, right? You can connect the JDBC connection, Java program you can do, or some, if you are using Python, right? So PyODBC is there. PyODBC. So PyODBC is a module is there. You have to just pip install PyODBC and then you can make a connection. Okay. Or other way of Hive connection is Beeline server is there. So Beeline is a thrift server. What is a thrift server? So the thrift server definition is like, suppose you are in the Linux environment and you are another environment is a Windows environment, and your client, like you are calling some like program from the Windows environment and you want to connect to the Linux environment. So thrift is a protocol which is providing a cross platform and cross language. Okay, so providing cross platform or cross language communication. Okay, so it is not a Hive proprietary. Thrift is a common protocol. So Hive has implemented this thrift. If I say HBase also implemented thrift, HBase has also implemented thrift. Okay. If I say Spark also implemented thrift. Okay. Another thing is we look at like mostly these tools are providing a REST API also. Okay. Why they provide a REST API? Because REST API is a very easy way to communicate to the particular tool, right? If I say, if I'm writing a Kafka, so Kafka is providing a REST proxy. What is a REST proxy? REST proxy is a HTTP interface calls are there. You can use some curl command or you can use Postman, any tool you can use. And you can talk to the Kafka by using the REST proxy. Suppose you don't have the command line interface interaction, you don't have, you cannot access the command line, okay? Or you cannot do the programmatic way. There are multiple ways are there, right? You can use either programmatic way, REST proxy, REST through REST or command line. Same like in a cloud you go, cloud is not giving only one particular way, just only console. Cloud also providing you the multiple ways to access. Like you can use programmatic way, some SDK API you are using. So these SDK APIs are like Python based API, Java, Perl, right? Different are there. Python, Java, Perl, right? As many as they are providing. Another one is a console access is there. Another one is a CLI mode is there. Like you have to configure AWS config, okay? And you can access, you need here access key secret key. So access key secret key you can get it. If you don't have access key secret key, the other way is the console. If you want to access to programmatic, here also you need an access key secret key, like Spark integration. So if I'm writing a Spark code, so I can write a Spark code here in any language, Python, Java, Scala. Okay. So these are the communication ways, right? What I was talking about here, the Hive is having storage is HDFS. Okay. But Hive is query interface is provided, query interface, which is interacting, which is getting the data, from HDFS, like stored as a files, stored as file. Different files data you can read, like CSV file, JSON file, XML file, Parquet file, Avro file. Okay, even Kafka you can get the data. You can get the data from Elasticsearch. You can get the data from Elasticsearch. Okay, HBase. Whatever you think, everything is there in Hive. MongoDB, you can get the data. Okay, but these are called SERDES. These are called SERDES, like C-lation, D-C-lation. They are the different types of storage handlers are there. So if you talk about Kafka, so Kafka storage handler is there. Okay, and if you say HBase, so HBase storage handler there. Okay, so this is some Java implemented class is there, like C-lation, D-C-lation. So it will not, simple table cannot read the data. Okay, if I simple word, if I say, so if I create a table, internal table, external table, so that table is just only comma delimited data you can read. That is a default. Okay, comma is default. But if you have a other file format data, you cannot read with the comma, right? You have to use some SERDES. Okay, so these things will come when I will show you, right? Okay, you can read all this different kind of data you can get in Hive, and you can get a data as a tabular. You will get a data as a table, right? And then you can query the data. You can underlying storage you are not worrying about. Okay, what type of format, even Parquet, Avro, these kind of file format, you can't read the data in the file system. You can't read. Okay, but as a table, you can do the queries. You can do the queries. Okay. So when we come to Hive, so Hive architecture is there. Okay. So when I say Hive architecture, so Hive is again further divided into the many components. Okay. Because Hive is a suite of components are there. Okay. So suppose if I say first is the client interfacing component. Okay. So what are the client interfacing? Like which is providing the interaction from any client and get the result from the internally from the Hadoop file system. Okay, so I say Hive CLI is there. Hive CLI is a Hive command line interface. So Hive prompt will come. Another one is beeline is there, right? If you are using thrift server, so you can interact through the beeline or some REST call, right? A REST call is there, or like you can do some Java program or anything. Like there are the different is there. So mostly we use this CLI and beeline, okay, when we are writing queries and we are executing queries, right? We are running our queries on the Hive shell, we will be using these. Okay, so another one is when the queries comes, right? Suppose in the Hive shell, you are writing query, select count star from table. Okay, so you are saying some query you are doing. So this query will be, there is a compiler is there, parser is there, right? Okay, so whatever you think about in the database engine, any SQL database, so same thing is here also, because Hive is completely SQL data warehouse too. Okay, so but it is a Hadoop base. The advantage is like SQL database cannot process the large amount of data in the multi-node cluster environment. Okay, because vertical scalability is there. But Hadoop Hive is, it's a like a distributed, right? So it can process the data in a multi-node. Okay, so compiler, parser, and database execution engine there. Database execution engine, which is converting query. So if I say my SQL query is converted into the MapReduce, okay. So who is doing this one? It is done by the Hive database execution engine. And finally, this MapReduce job is run, is run and get the result. Get the result to the interface, right? Query interface, right? CLI. Okay. And one more important tool is there that I didn't tell so far. That is the MetaStore. Because what Hive has done, the storage part and metadata, right? Storage part is the actual data. Storage on HDFS, that is actual data. Okay. But this actual data need to be fetched by some metadata, right? How can I come to know how many columns are there, types of columns are there? So that I will come to know through MetaStore DB. So MetaStore DB is a separate database. Separate database. In case of Hive is Derby. Okay, but you can make it your own database also, right? Suppose you say, I want to keep it my own Metastore data in MySQL, Oracle, anywhere you can keep it. Just you need to configure it. Okay, but Derby is given by default, and it's a very small 10 MB database. So that is given by the Hive. Okay, and this Derby is having one table, TBLS, and this TBLS table containing all the metadata information like table name, what type of table it is, whether it's a managed table, managed or external table. Okay. So two types of table is there, managed or external. And after that, column names and column types, column names and column types. So this all information is there in the metadata. So first query will go to the Metastore DB to get the all meta information, and then it will run the query, right? The MapReduce will, like, this query will be converted into the MapReduce accordingly, and then get the data from the actual storage from the Hadoop file system. Okay. So this is our internal. Some more detail is there, like logical plan, physical plan, MapReduce plan. So that is the reason the MapReduce job, right? Definitely it will be slow. But when we are not concerning about time, right? We are having a huge amount of data. Definitely the huge amount of data will definitely take time. Okay. But when I want to still more processing faster, then we go to the Spark. Even the SQL queries in Hive, we are running through the Spark. Okay. So we can access Hive through Spark. There is a spark.sql, and you can use like this, use database name, and then after you can write spark.sql, and you can get same query. If I write like this, select count star from table, so this will access the Hive table, and it will get the result as a data frame. Anything is coming from the spark.sql, it will be coming as a data frame. Suppose I'm using a PySpark code, so res result. So some result variable, I will get this data. And when I do res.show, I will get the count, show function to show the result. So I will have another option is there, right? I can use Spark for more faster, because Spark is running the job in memory. And that is the reason, because Spark needs always the higher memory configuration. If your memory configuration is not high, you cannot run efficiently the Spark job. Okay. So that is the reason memory is not a big constraint, right? Our main goal is to run job faster, right? So that's the reason we cannot compromise on that. Okay. We go for Spark. Okay. But sometimes but Spark, you have to write an entire program, right? If I have to just run this simple select query, and I know if I want to write a program and then after create like I have to put on cluster and do the Spark submit. So a lot of effort is there, like, okay. But if I really want to do some transformation things, then definitely I will go for Spark, right? Because the transformation, if I do Hive, it will be taking a more time. Okay, so these were all the component of the Hive. Okay, so now next thing is coming. Anyone has any question, doubt? Because I talked about approx 50 minutes. So I'm asking to you, right? Anyone like want to ask anything, question? Hmm. I will share the classroom links videos, my previous classroom link videos. You can follow that. YouTube also you can see. Okay. But see, watching videos, it will not helpful you unless you do practice, right? Even though you Hadoop command practice or you do Hive commands or Hive queries, as well as not only queries like partitioning, bucketing, surveys, UDF, and HBase, right? You are creating tables and like some first you need to understand each and every individual component and tools, right? And then once you're done, then you will be doing the integration, not only one or two tools, maybe sometimes you are using 3 or 4 tools together as integration, like Spark is reading data from Hive and writing data to any SQL DB or no SQL DB. So there you need to learn the pipelines, ETL pipelines, and ETL pipeline is not only one single tool is there. When you're talking about the ETL means extract, transform, load. So you have to extraction part is there and finally loading part is there. But in between transformation, you will be doing a lot of transformation you're doing, right? So that you will be doing any, like you can do even Hive you can do, or you can do in Spark, you can do anywhere. Manipulation of the data anywhere is possible. Even the Kafka also you can do. Kafka streaming also there is a, if you don't want to use the Spark, right? So it will be depend, right? Okay, what is the client requirement and what type of processing they want, right? Okay, if you want to think, okay, you are getting already Kafka like streaming data and you don't want to go with the Spark. So one way is you integrate Spark and get the data in Spark and process the data. But if you don't want to use the Spark itself in the Kafka streaming is there. So you don't need to go to that type of processing like what Spark can do. You can use Kafka streaming. There is a KSQL is there, okay, and Kafka SQL query language is there. So all lot of options are there, and Kafka Connect is there, which is providing you the ETL pipeline. Kafka Connect, very powerful, and it has like 150 integrations are there. Any tool you think about it, you can get the Kafka connector. Okay. So you can read data Mongo, you can write data to Cassandra anywhere, from anywhere to anywhere. So this is also ETL, right? Kafka Connect. So it's depending on the choice. Okay. Yeah. Anyone has any question? Because I will be showing next is a Hive related internal table, external table, all those commands. Okay, let's wait for the 5 minutes. Okay, I will start the internal table, external table, partitioning, and Saturdays. We'll start. Okay. Okay. So first of all, like how you need to install Hive, because once you install Hadoop, are you getting my voice, right?
Yes, sir.
Okay. So first thing is like we installed Hadoop, okay? Or you are using EMR cluster, there you will get the Hadoop, okay? And you will be getting the Hive already there because everything is installed by the EMR. But when you are installing in your Ubuntu, first you need to install Hadoop and then you have to install Hive. So Hive is also having some set of steps are there, okay? And we can follow the link for the Hive. So Ubuntu Hive installation. So very simple steps are there, okay? And you can follow. First of all, you should have the installed Java and Hadoop, and then you can go to the official website of Hive here and then download the release. And this particular release we have to download 3.1.3. You go, and there is a bin tar file. So this file you download and then extract this tar file. Extract this tar file. This is the same thing, and then you will set the Hive home path and bin path. I will provide the document. Some of the mistakes are here in the website because here is a space is there, this space. So this will not work out and slash should come. Okay. And you have to change your user home directory and change this. You can give the path. Okay. So this all steps you follow. And once you complete this all steps, after that you can start your Hive shell, right? Just you type Hive, your Hive will be started. If you have not started the Hadoop services like start all.sh, then you will get the error, connection refused error you will get because it needs a Hadoop file system. Okay, it is connecting to the Hadoop file system. So it will be checking the Hadoop file system. It is not able to connect. It will give the connection refused error you will get here. Okay. So you make sure whenever you starting Hive, before that, you just check your Hadoop is running. Okay. So once you start Hadoop, right? And once you start the Hive, okay. Okay. So once you going to start the Hive, so simply you will type Hive, okay. And Hive is like providing the as a SQL query interface to you like this, okay. So first thing you can check, very simple, show databases, and you can check how many databases are there. It's the same commands you use in the MySQL, Oracle, right? So these are the databases commands. So commands are same, and you can create your own database, create database, and you can say here Oracle 6. Okay. So I'm creating a one database, create database command, and select current underscore database. Suppose I'm not able to see, okay, first I see here what is my current database. Current underscore database. This is a function database. Semicolon is needed every time. So by default is the default database. If you don't select your own database, like use command, you know, right? Use command to select a database, right? In which database you want to write, you want to create a table, you want to select query. So you have to use database. Otherwise, it will take the default. If some table you are giving, which is present in your database, and then you are trying default, it will give you the table not found. Okay. So make sure whenever you are going to use, you just give your database. So April 6th, and then I will use my database. Now I do the again same command. So I will find what is my database. Can you see here April 6th is coming. So sometimes whenever you are not able to find, right, okay, in which database you are there in Hive shell, right, there is the one more command is there. Even you can display here your database name. Okay, I need to check that command. So you just write command and then your database name will come here, okay, along with Hive. Okay. So now I have used the database. Now I check the tables, show tables. I am able to see nothing is there because I haven't created any table so far. Okay. So now first thing is, okay, we understand. And one more thing is, in the Hive shell also you can run the Hadoop command. Generally, you go to the terminal. You go here on the terminal, right? On the terminal, you will run the Hive command, right? Generally, you do Hadoop fs minus ls slash. You do like this, right? And then you are able to get the Hadoop command run, and then you will get the result. But suppose if you want to run the same thing in the Hive shell, use exclamation mark hadoop fs minus ls slash. So this exclamation is indicate like you want to run some Linux command. Okay, even you can run the local command also ls. Suppose you want to see in which directory you are there, just run pwd command we know, right? Okay, so just it is telling me this is my pwd. If I want to see ls command, semicolon, I'm able to see this is my list. If I want to do LL, okay. Okay, LL is not working. Okay, so ls minus lrt we can use. Okay, ls minus lrt. See, you can see the list of files you are able to see. So first of all, you don't need to go to the terminal. You can run even the Hadoop commands or Linux command you can run in the Hive shell. Okay, that is the first thing. Now I'm going to create a table here, right? Abhi, right now I showed you there is no tables, right? There is nothing, right? No tables. So first I will see, right, how many types of tables are there. Okay. So there are the two types of tables are there in Hive, internal table and external table. Okay. So basically the people know about the difference, right? Internal table and external table. Like internal table is the table which is created in the warehouse directory. What is a warehouse directory? The warehouse directory is the user Hive warehouse. This is the internal directory where the data is stored, right? Whenever you are writing data in for the internal table, it will be stored in the warehouse directory. An external table, this is for internal table, right? So inside this warehouse directory, it will create a one DB folder. So what was my DB name? 6th April.db. So this folder will be created. And inside this folder, your table folder will be created, like EMP folder. And inside this EMP folder, table name folder, your file will be stored. Suppose my file is a test.txt file. So my data will be stored in this hierarchy. But external table is not constrained. If you are not giving a location, external table, if you are giving two things are there. If external table, you are giving a location. Suppose I say my Hadoop location, I say my Hadoop directory is there, 6th April / I say internal. In this directory, if I'm storing the data, I'm giving a location. So my table data will be stored in this directory. So if I say the test.txt file will be copied here, the test.txt file will be copied here. Okay. But if I'm not giving the location, so external table I'm creating. So external table is created by external keyword. So by default, it will take it same warehouse directory, the same thing. So if location is not given, then it will use the same as a internal behavior. Okay. This is the one difference, but I say that this is not a major difference. The major difference is in internal table and external table is the internal table when we drop table means like I want to delete the table. Generally we drop table means I want to remove the table. If I drop table, my table and schema both will be deleted. My schema and data both will be deleted. Okay. So it is very careful because by mistake, if you have drop table you did for internal, your data will be gone. Okay. So generally this internal tables are in the warehouse directory because this warehouse directory access is people are not there. Generally they are not giving access because internal table there is risky, right? If anyone like by mistake deleted table, so you can create table again, but data you cannot bring, right? Because data you have to do again the same exercise. The last time, how did you bring it? So manually you have to bring the data again. But in case of external table, we don't need to worry, because even by mistake or like intentionally, if you drop the table, your schema will be deleted. So when we drop table, only schema is deleted, not the data. Okay. So same schema like command, we have a create table command, we can recreate the table. So your data will be deassociated. Okay. What internally happens, like when you drop a table, external table, your data will remain at the same position, same location. And when you attach, when you recreate a table, and the same table, we can create and make it data associated with the table. Okay. We will see this thing as a practical, because this thing I will show you the practical. This is very simple thing. First we do with the internal table, then we will do the external table, how it happens. Okay. But the first we need to theoretically concept, right? What is internal, what is external, why we go for internal. But mostly in the development, like if I say we go for external tables, right? Okay. Okay. So once we do this, the next thing is like we know, right? There are many more things are there, right? Data definition language, data manipulation. So those are coming as the same SQL concept. Okay. So database has tables, and tables has columns, which we call it fields. Okay. And rows. Okay. And this structures, rows means records. Okay. And then we are getting a tabular data. Okay. And the other concept is that like we have different data definition language. Okay. DDL, DML, okay. DCL, data control language, DCL. Okay. So we can change the structure of the table, right? We can alter the tables, right? So this all comes data definition language, because we are defining the table structure. Okay. So DDL. So create, alter, right? All this modification, whatever modification we are going to do, all things will come. So alter can be at multiple level, like table level alter can be there, column level alter can be there, right? So we can alter the column, alter the table, like table rename is there, right? And data manipulation language, right? It is inserting data, loading data, inserting data, right? So we can do data loading from the file. So data loading from files, we can load the data, right? The bulk data. So Hive is not meant for single record. We doing like 100,000, 10,000, 50,000 records in a one go, right? Because we are not loading one record, because it's not a transactional data. It's a historical data. We are talking about Hive is data warehouse too. So Hive is not a alternate solution for the SQL. So we can use it, but the main purpose of Hive is analytics, like transformations, like we want to do the historical data analytics. That purpose we are going to use Hive. So that is the reason we are loading the data, loading from the files like different SQL file, or the CSV file, JSON files. So I told about there is a survey will come in picture, like JSON survey, XML survey, CSV survey, all these type of surveys will come. Okay. So data loading from the files, and table to table loading is there. So table to table loading, suppose I have a table of 10 fields, and now I have a new table. I have to do some transformation, and I want to load only 5 fields, because only 5 fields are I have to use for reporting. So why I need to take it all 10 fields? So this kind of data insertion will be happening table to table, right? Okay. And another thing I will be going to tell about, this DCL is related to permission things, right? We don't want to give the access like ACS, access control list, RBAC, okay, rollbacks, access control list, right? So like we want to control over the tables, right? We don't want to allow anyone can access this table, or anyone can only have the view access. Okay. And data masking is there. Data masking is like for security, right? I want to, the PII data is there. You guys heard about the PII, personal information data, right? That is in the healthcare industries, right? So we don't want to expose the data to the end users, right? So that is PI data masking, security, encryption. Okay, all these things are there. Okay, so Hive is providing everything. Okay, so which level of like a manipulation we want to do, we can do it. Okay, and Hive is the main important part of the Hive is partitioning. Okay, that is the very strongest part is there in Hive is partitioning. So partitioning is, let's understand this concept this way. Okay, suppose I say I have a one table. Okay, and I'm doing select star from some table is a EMP where city equal to I say Delhi. Okay, I'm just talking about one example. So you know, right, if table has 10 record, so it will easily give me the record, right? Because 10 records, it's hardly check all record. It will check one by one, each record where city is Delhi, right? It has to check, right? Without checking the city Delhi, it cannot get it, right? Because each record it has to check. Okay. Instead of this 10 record, I have 100,000 record. Okay. I'm saying not 10 record. I'm having 100,000 record. And I'm saying this out of 100,000 record, only one record is a Delhi. One record is Delhi. Okay. So can you think of, right, it has to check all 100,000 record, right? Because scanning is needed, right? The scanning is needed for entire record, entire number of records we have to scan. And for it will take the time, okay? So if I have done the partitioning, so partitioning is a logical way. Partitioning is a logical grouping of the data, logical grouping of data for some column value. Okay, so suppose I'm saying I know in my city column, 10 different cities data, 10 different cities. Okay, so how many partitions will be formed, right? Definitely the 10. But suppose I say my city column has 100 cities. So 100 cities, 100 different cities are there. How many partitions will be there? 100 partitions. So depends how many number of different values are there, it will form the partition. So partitioning are the two types. One is static, one is dynamic. Okay. So static means it is manual. Static word is very like informative, right? Static means something you are going to do static, right? There is nothing dynamic. And dynamic is the automatic. Automatic means like it should automatically detect the number of partition in your column. You don't need to put effort. But static is you have to put effort. But then why they static giving, right? If they're putting effort, right? So why? So static they're giving if the number of partitions are less. Okay, just can take an example. I have a data and I have a one column gender, right? So I'm saying gender male or female, right? So I can not have more than two, right? So this kind of thing is there, then I can go for static. I can divide the file into two parts, one for male data, one for female data. And dynamic partition, we will use it where the data is dynamically coming and where we don't have any anticipation, right? How many partitions can be formed? So here, static, you are loading data manually in the partition table. So definitely you need a one partition table. Okay, partition table you need. Okay, let's do first practical of like internal and external table. You understand first how to create table and how to do. Anyone has any question? Internal table, external table? Okay, so these documents I will share to you because these are same thing, whatever I'm explaining, I have written already. Okay, so first we go with tables creation. Okay, internal table and external table. So internal table is like when I'm not having any right external keyword. So that will automatically a internal table. Okay. So I'm just going to create a one table. And this table is the internal table and it has how many fields are there? Two fields, ID and name. And I'm using here row format delimited and fields terminated by comma. So I'm defining it like when I'm reading my text file, I'm reading a data from the file, right? I'm creating some text file and where I'm reading the data. So how I should parse my data. So I'm not using a survey here because it's a very simple text file data and comma delimited data. So I can use it simple, very, very simple create table command, the row format delimited and field terminated by. When I will use external table, I will put an external keyword here and the last I will add location, LOC. Okay, I will show you here LOC, location. So location is the keyword you have to use and give the location path of your an external keyword also you have to use. Okay, let's do. Okay, I'm going to create a table here and I will do show tables. And anytime you want to see your table structure, right? Suppose I created table before and I want to see what table structure look like. So we have a command show create table. Show create table. Just I'm saying show my create table syntax and say test 1, 2, 3, 4. Okay, so it will show me my table structure. Okay, how internally it is. So it is showing a warehouse directory. You can say here the directory location is the warehouse and this is the db folder is created and inside db there is the folder of my table name and this particular location. If I see the data right now there will be no data. So hadoop fs minus ls and I will be running this command. So I will see nothing is there because I have not loaded any file. Okay. So I don't have the data now. Okay. I create a one folder and I will create some files. Okay. So I'm creating a one file cat internal.txt. Just any name you can give internal.txt and I'm writing a data. I have to define two columns, ID and name. So I'm giving a ID, name, test. Okay. ID, name, ID, name. Okay, just keep it three field. And now I'm saving this. So now I have a file here. And what is the path of this file? Okay, I have to go. Okay, I created a file out. Directory I created, it is already having the, why it didn't give the array? Okay, so my file is created here. What is my file name? I'm inside my directory. Oh, you know, right, what I did? I created a directory name is hive est3 and I logged in the I cd I did hive test 3. That is the reason these things I was surprised because my directory should be empty, right? Okay. So the surprise thing is here I I cd command I did hive test 3 and hive test 3 already so many files are there. Okay. So you understood, right? What happens, right? That's the reason I was surprised. You guys understood, right? What happened? It's a typo mistake. Okay. Okay. So, okay. So now I have internal.txt. Okay, so my file is there. I want to load the data, this internal table. So there are the two ways to load the data. One is you can use load data local in path and give the directory path home slash my username hive test3 slash internal.txt into table and table name. My table name is test1234. Okay, so data is loaded and I will now query the table test1234. So I can see the data I'm able to see. If I go to the location, last time I was showing you the location, right? So I will show you the location, this one. So I will see one file is copied. So this load data local path command, can you think of what it is doing actually? It is just copying the command. If this same thing is done by this load data local path command, so can I copy directly put command? Okay, if I don't want to use, okay, so I'll show you. So if I drop this table, okay, if I drop this table, drop drop table test1234. So when I drop this table, when I will see my this data location is also removed, right? It is not able to find because my data and schema both are deleted. If I do select star from table, that is also it not able to find. So my table and data both are deleted. Okay. So now I'm creating again the same internal table and I will, this time I will load the data by using the by put command, hadoop command. Okay. I created table again, same table I created again. Okay. Now, instead of copying the data by using the load data local path command, I will copy the hadoop put command. And the same location, where is my directory is there. My directory is user hive warehouse, this directory. This is my table directory. I will copy the file here. What is my file? My file location is /home hive test3 slash internal.txt and I'm copying the file on this location. When I copy this location, now I will do select command, select from test1234. So I will be able to see it's the same, right? Either you use load data command or you use the hadoop fs put command. So this will be applicable to any type of table. It is an internal table or external table, it doesn't matter. This is just a way of loading data. So this is just a way of loading data, whether the table is an internal table, external table, or partition table. So partition table will be there. So just partition will come in picture. Otherwise, the command will be the same. Okay. So now if I just going to create a one external table. Okay. So first of all, like if you're trying to create a same table with the external, you will not be able to create because it will be giving you error. Okay. So now I'm going to create a table with a different name. And this time I'm giving a location keyword and I'm going to write data in this location. This is a root directory. I have some directory folder. So I'm creating a external table. And this time I will see if I see the location of my underlying data storage, okay, for this table is my Hadoop directory. So I will see this table, this directory. This is my directory. So right now this directory will be empty because there will be no data, right? Now same thing put command I'm going to use to write the data here. Okay, so I have already the put command. So this put command, the location of the input file is the same location because this is not changed, right? Only difference is like now my this external table location is changed. So I will be giving the path of table data 1, 2, 3, 5, 4. Okay. So I will write the data. I will write a file over here. I copied the file in the same location. Now I will do select star from table. What is the name? Test 1, 2. Test 1, 2. Okay. So I'm able to see the data. So it means the data is there. Sometimes the scenarios are there, your file is having more columns, but your table has the 2 columns. Okay. But it will take the data from whatever column is matching. Or sometimes the scenario, your table has the more, right? Like a less column and file, or table has more column and file has the less. So, and here is one more thing is like whenever your data and type is not compatible, it will not give the error. It will be doing the null. So that is the reason Hive is called schema on read. Actually, there are 2 concepts are there: schema on read and schema on write. So any SQL database table is schema on write. It is checking the schema at the time of writing data, schema on write. So any SQL database is called schema on write because the validation of the schema happen at the time of writing data in SQL table. Okay. So that is the reason it is called schema on write. Okay. And SQL table takes more time to write data because it is validating that schema. SQL table takes more time to validate schema. Okay. So that is the reason it is not faster. But if you say Hive is schema on read. Hive is not validating any schema at the time of writing. It just write the data, dump the data. And if you say 50,000 records you are writing, just 10 seconds you will write a 50,000 because it will like a dump. It will dump, right? So schema is checking at the time of reading data, selecting data. Okay. That time it will give you the your type is not valid, or it will be giving you null values. Okay. Selecting data from table. So it is more faster while loading data into Hive table. Okay. You can practically check, right? If you have a file of 100,000 record, it will take fractions of second. It will write. Okay. It will not be taking more time. Okay. Okay. So here we have loaded data into Hive table, internal table, external table. Now we do practical on the external table. Now I'm going to drop this table. Drop table test12. So I drop the table. So if I check first my data, okay, whether my data is deleted or not. If I check this 1, 2, 3, 4, 5, so still my file is there. My file is not deleted, right? But if I do query, select start from test12. So I will see my table is gone. So if I recreate table, if I just copy the syntax of the table, so I will get my data back into the table. So just I'm creating external table again with the same name. Now if I do the select start from table, I will able to see the data. The data is on the same place, just you are making association deassociation. Okay, so that way we are working with the external table. Okay, next thing we come to the partitioning. Okay, so let's start partitioning. Okay, so we'll understand both static and dynamic one by one. So this is all things same as second way of loading data. Okay, you can do practical easily. Now we come to the partition. Anyone have any question? I will start partitioning. Okay. No question, anyone? Okay, everyone has already done. Okay, so so understand the partitioning things. Okay. So I already discussed the concept, right? I'm not going to tell again. Just concept I told you why we need partitioning, and partitioning is very important for the performance. Whenever you talk about like my Hive tables are slow, right? So these are the performance tuning techniques are there, right? Partitioning is the one, like joins you are using, the join you are making it faster, right? And push down predicate you are using, or you are using vectorization. There are so many techniques are there, you will apply it in your Hive tables. Okay. So performance is very important, right? Basically, you want to get the data faster from your SQL query. So you will be improving. So partitioning is one of the major technique, right, to improve the performance. Because I already told you scanning we don't want, right? We don't want to the whole table scan. But partitioning is like you have to choose a one column, like one partition column, right? You should decide. Suppose one table has multiple columns as a partition columns. So you will create a multiple like partition tables, right? I say like you can keep it nested partition, right? You can keep it like, okay, country is having a state, right? And state is having the cities. So country is a high level partition. Inside that state is there and the city is there. So partition means like when you are using in your where class, then the data will be found from the partition. It will form a partition and it will get the data from the value which is formed by multiple columns, and then it will get the data. So I'm creating a one table. In here, I'm saying one student name is there, father name is there, percentage is there. This is a student data. But student is divided by the sections, right? Where there are different sections of the students are there. So I will prepare the data like I say one section A is there, one section B is there. And I'm loading this all two sections data manually, right? I'm saying load data local in path and partition wise loading the data. Because if I don't load the data into the partitions, how can I get the data from partition? Okay, if you try to do select star from table and you don't give the section, will you get it A section data? No, right? You will not get it. So you have to give the clause, because partition meaning is like you are willing for not the whole data. You are willing for getting the data only for a specific column value. So that you need to specify, then you will get the partition. So this is just simple. These steps you do, your static partition is done. Okay. But static partition, like, okay, you are doing a table to table partition also you can do. Like one table to another table also you can load the data. So there is a two cases, right? You can load the data from the files, but generally file case is like less number of partitions are there, definitely you have five. But if I say I have to create a table with the 100 cities data, will you load manually one by 100 partitions? No, right? You definitely will not go for that. So in that case, you will use table to table. But again, either you use table to table or you use file to table. In both the cases, you have to run this load command or insert command again and again. Because when you are loading from the table to table also, here you have to use insert into command. So insert into command is used for table to table and load data command is used from the file to table. But in both the case, static means you have to, number of times you have to do either insert command or load command manually. Okay. So that is the reason the dynamic will come in picture. Only one single insert command will load the data for all partitions, whether it's two partition, whether are two partitions or 100 partition or 1000 partition. Okay. So that's not your responsibility. That's a Hive responsibility, how it will detect the partitions and get the loaded data into the dynamically into the partition table. Okay. So first we are going to create a table. Okay. And now I have to prepare the two files. So section A file and section B file. I'm copying the data and creating a file. Or maybe I have the already file there. Okay, section A is there. Cat section A. Cat section B. Okay, the two files already created. Okay, section A, section B. Now I want to load the data into partition table. So very simple command. So till here, this command you can remember. This command you can remember. Only the last part is partition and partition column and partition. And how this partition table is created. If you see this partition table is created, this partition table is created just giving an extra one more line is partition by. Because this partition by table column you are giving, this should not be the part of table. It is the logical column. Okay. So always remember it whenever you are creating a partition table, this partition column should not be part of your table. Okay. Logically is dividing the data. Okay. So you are not physically doing the separation. That is done by the bucketing. So next concept will come bucketing. You will understand one partition can have multiple files, and that is called bucketing. Okay, so bucketing is a further level of enhancement you are doing in a performance. Okay, because partition is doing the partition level, but bucketing is the like a particular ID you want to fetch in a buckets, multiple files. How can you search? So there is an indexing is there, hashing. So hashing is a very common technique. It's a hash value, generate the hash value. So anything you can generate the hash value, and this hash value put a particular record in a particular bucket. So how can you come to know this particular record ID is in particular bucket? That will tell the hashing. Okay, so hashing. So suppose you have 100 partitions are there. So would you like to find a one single record in 100 partitions? So I say the bucketing will make you in one partition, right? Suppose you find the partition, which partition your data is there. In that partition, if 100 files are there, you can get by bucketing, you can get that one record. Okay, so let's do this. I have to change this path. Actually, this is failing. So I have to change it here. So my table is student 1 to this meeting. Student 1 to ST80, and this is my hive test 3. And I'm saying the partition you create with the name section A. So always remember here, like static partition is very careful, because if you have done some mistake, either defining the partition name or defining the which data you are writing in which partition, which file. So if your this all things become interchange, your data will be messed up, right? Suppose this section A file, you have to write in the section A partition, but by mistake you have written in the section B. So your data will be messed. Okay, that is the reason dynamic partition is very good, right? Because you don't need to worry, because everything is done by the hive. Okay, because here this kind of mistakes can happen, right? Because you are copy pasting. Suppose second command I'm also creating, 2 times I have to load the data, right? So one time is I'm saying section A is section A and section B is section B. So when you are running this command, because you can by mistake, right, you can write suppose same section A data again you written in the section B. So that kind of things will happen. Okay, so I'm writing data in path. Okay, and always like when we are copy pasting now this single code, right? This is we have to rewrite, okay, because you will see this single code is looks appearance is different. Okay, so always rewrite it, because or better to write your own write command, so you will not have any possibility of any mistake. Hash home. See, it is so quick whenever load data you are doing. Okay, now second one we are doing B. So I will be loading B to section B. Okay, B to B. And now I do query, select star from student 1 to underscore ST80. So when I don't give any where clause, it will be coming the entire data. But suppose I want to get the data from the partition, I say section single quote A, because it's a string type of column. So this is coming partition. So you will not say, okay, why I'm not getting so quick, right? Because it's less data, right? When you have a very good number of data is there and you have only one single record, then you will see. So this data is already be prepared before, right? Because in the partition means when you're creating partition table, that time only the partitions are distributed. Okay. But generally you will be using the values which are the like static means you are loading data manually, right? You know already 2 sections data is there. That's the reason 2 partitions are there. So A and B. Okay. So this is we see the static partition. Now static partition table to table we can do, but in that case we need some source table, because source table where we have all 4 columns should be there. So I will create a table which is the source table. So single code you always remember. So this you rewrite it. So now this table is a source table. Source table is all 4 column data is there. Okay, because I'm saying instead of writing one by one file, I will take it one by one for each partition, but from a table rather than keeping it multiple file. Okay, so here I will load the data. So I will have one section file. So this one is when I do load data, so there is no partition in this, and I will say student underscore source 1 2. This is my table, but my file name is section. Like some file name is section, which has all section. So I have to check my file is there or not. Sections and sections. So which one is cat? TTION. There is no T. CESETIO. Yeah, it has section A and B. SECTION. Text also there, right? Section.txt. Okay, data is loaded. So my source table is the same like a general table. Okay. And it could be an internal external depending on the, it will go warehouse or where it will go. That will be different. Now I will do insert into table command to load the data from this source table. So A values data I will load into A partition, and B data we will load into B partition. So I will create a one more partition table also. So I will create a one partition table, and this partition table, because I'm just not mixing the data, so that is the reason I'm creating a different partition table. Okay, so I want to show you this partition table is like table to table. So that is the reason I'm again creating the same partition table. Okay, once this partition table is created, now I have to do not load data local command. I will use insert into table section A. Here the partition name will come, and select column name from the table and where section equal to A. So how many number of times I have to run this query? Because it's static, I have to run 2 times. So one for section A and one for section B. Okay. So it will be running a map reduce job. So here the map reduce is coming in picture because it's not just loading data from the file. Okay, so it is running a map reduce job. So map is 0%, reduce is 0%. Initially both are 0. Okay, map 100%, reduce is 0%. Okay, because here is no calculation, right? Just simply loading data. So my data is loaded for one. Second one is section B, and I will load the data into section B. Section B, section B. So this is my second insert into table command, and this is a static partition. Okay, so both are the static because manually you are running a insert command or load data command, right? One by one. Okay, so that is the reason it is called manually, because you are preparing the table data of your partition table manually. Okay, so once this both are loaded, so now I can query select start now. The end result will be the same. Even the dynamic partition result also you will see it is same, nothing difference. The only way is how efficiently you can do the partition, right? Either static or dynamic. So what is having more effort or one is having a less effort. Okay. Where okay, so this way you can get the data. Now let's go for dynamic partition. So when we go to the dynamic partition, so same table, dynamic partition also the same table. Okay. So I'm just going to create a table, same dynamic partition. Okay. So I created a dynamic partition table. Okay. Just I'm creating a table, different table, because I don't want to mess up with the existing table. So I just showing purpose, right? Like I can clearly show the data. That's the reason I'm doing. So you will see now I have to run only one single insert command. Okay. I'm trying to run this insert into command, but here I will not give any static value. Can you check it here? I'm giving any static value here. I'm not getting any static value. I'm just giving partition. Last time what you did, insert into you use, but here you given partition section equal to A. And you are saying here the columns of your, but one difference is there. The last column of the selector, now it should be the same partition column. If you have mismatch it will not work. Okay, suppose I do percentage later after section, right? See, this is a thumb rule, okay? Because if you're trying to do, it will not happen. Okay. If you, first of all, like, okay, the static partition is a default partition. We know, right? It's a default. It automatically like it's a by default given by the Hive. But dynamic partition is not default. You have to enable it. You have to enable in the Hive session. So when you try this, what is saying? It is saying dynamic partition strict mode require at least one static partition column. First of all, you make it enable it by using this property. Set Hive non-strict property. You have to set it this. Okay. Or otherwise you use as a static partition, because you are trying to make it use of the dynamic partition, but you have not enabled the dynamic partition. If you don't want to use dynamic partition, give a static value. Okay. So it's a contradict. Okay. So you have to enable this set property. Actually, one more property is there. Set Hive execution dynamic partition equal to true. Okay. But that property is not that much crucial. It will be, this will be allowed. Okay. Another property is Hive execution dynamic partition equal to true. This is the property. Okay. Second one, if you don't want to use, if you don't use, that is fine. Now, if I'm running the same command, see, this time this command will work. Last time it was not working, but this time is working. Okay. So now both the partitions will automatically populate it in one single command. Okay. So the idea is here, right? This is a dynamically loading partition by using the dynamic partition, because you don't need to manually do insert into them. Okay. Okay. See, now if you show partition command is there, I will show you how manipulation on the partitions you can do. You can check the partition, you can rename the partition, you can copy the partition. Lot of partition management we can do. Even you can add a new partition. Partition is not just like you done partition done, right? You cannot add, you cannot create a further more partition, because the create table command you are doing partition, that time partition when you are loading data, that is a one. But alternatively, you can add more partitions also by using the alter table add partition command, or you can drop the partition. Suppose you want to check how many partitions right now. Okay. So one way is like through command you can check and show partitions and table you can give. And another way is like you can check the location of the your data. You can find the your there also you can check. See, so it is partition, it is A, B, C is. Oh, okay. It has, I have run the, oh, last command percentage basis it taken. Okay. The thing is, it is not giving error. Okay. What happened here? You told here section. Okay. And what it understood, this percentage is a section. Okay. So Hive is not defaulter. Like you did mistake. It is your mistake, right? You know the section is there. The section should be the last column. And by mistake, what you did, you make it this section not a last column. So if you didn't do, it will not give you the error. It will give you the wrong result. So what wrong result you are getting? You are getting that 4 partitions, and with the percentage basis, the partition is divided. So now you will be doing the value like section equal to 23.0. Then so now you will see the data. So let's start from this table. See, this is the thing. The data is completely disordered. Okay. If I check the column of my table, you will see like first name is student, correct? Father name is correct. And this column is gone, right? Okay, so section, it has understood this one. So your data is like 4 partitions are created of 4 different values. Can you see here? Like one value is this, one value is this, one value is this, one value is this. Okay. So always right, if you are following the same rules, syntax, then you will not get the any issues. Otherwise, errors will not come. You will get the data mess up, right? You will not get the data. So this is very small partitions we are doing, but suppose sometimes you are loading the very huge file, and if you have done some mistake, what will happen? Like you have to delete entire thing and do rework again. Okay. So a small mistake, right, can make you like again rework. Okay. So this is very careful, right? Because you should know which partition column you are using. So dynamic is also careful, because blindly you cannot just write the sick query and then you assume it like everything will go fine. Okay. So you are thinking there is no mistake here, right? Even I write here or there, but ideally, whatever the best practice and whatever is the rule is there, that we have to follow. Okay. So we can add a partition, drop partition, we can copy partition, we can rename partition. A lot of things are there. Okay. So that is called partition management. Okay. Okay, let's do tomorrow. Okay, I will complete some more section on the hive. Okay. And hive is very interesting, and like especially when you are working like on the Saturdays, UDF, right? And it's a moreover command things, nothing programming, right? You know, SQL, right? So you will be getting a more good hands-on the SQL. And especially one book I shared, right? So you can try this command. I didn't try, like different complex data type is there in hive. Like you can create your own data type, right? Array is there, struct is there, map data type, right? So this one I have to tell, okay. And some more like views you can do. So this book chapters are there. You can go to the, like I have shared the like packet pub, right? This link. So hive essential book, Google Drive is there, this one. Oh, not this one. So hive essential packet pub. And book I also shared in my like in the group, and GitHub also there. Okay. So this GitHub link, you download the entire GitHub link in your Ubuntu and do practice. Data is there also. So just this is the 4 files are there, and this is a script. And these scripts are the chapter wise scripts are there. Chapter 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 10. So till here you can go through this entire book I shared also, and you can practice like different union intersections. See, these all things I cannot teach because this is more SQL thing. I want to tell hive related things. I want like you should practice on these things your own, right? Because these are the SQL concepts, and you will not get any difficulty, because if you know SQL, you can very well do this join on union. All these things are the SQL. See, hive has the capability of doing the things of SQL, but SQL database cannot do the things hive has. Okay, because hive is more capable. Okay. So everything, whatever you check in the like these all chapters wise chapter, you can run, and very simple commands are there. You want to select queries, sort by. So this all I will tell tomorrow. One order by, sort by, clustered by, like how to create partition bucketing. We can do partitioning. We finished it, and like this multi insert, right? How to write insert queries, right? And common table expression, very important, right? CT. right? How can we windowing functions can be used? You will find here in the windowing function in the some chapter, I think 5 or 6 something windowing function is there. Okay. So windowing function is a rank, dense rank, okay, row number, all those functions. So it has clearly told here, like just change your path and load data. And after that, you can do partition management here, right? You can see here, you can, this is, the important. Yeah, this is the windowing functions queries over partitions. This one, these are the queries. One chapter is, yeah, 7 chapter is related to indexing and like tables, right? And this, these are the performance tuning related, like how to do the map side join and factorization. Those things are there. Yeah. Sure. Okay, 8 chapter is a UDF. I think 4 chapter will be there. Partition management. Yeah, here is alter show partitions here. So from here you can see the command show partitions, partition table name, alter table, like you can add more partitions. Suppose 2018 11 month not there, right? So you want to create a new partition and you will load the data into new partition. And you can like drop the partition, right? Suppose some partition you don't need it, right? So you have to drop partition command and remove the data also, because it will not automatically remove. And there is a msck repair command is there that you can sync your partition from the data. Okay, so these all commands are there. Okay, so okay, let's connect tomorrow. I will share the recording and document in the OneDrive folder. So yeah, I will share to you. So I will share. Okay, so whoever is not in the group, right? My group, just give the email ID here to me. Okay. So who are already in my regular class, so they don't need to give. Other people who are new, right? So they can give me the email ID. So I will share that, right? Okay. Just share it here to me, or you can share me on the WhatsApp me one-to-one. Okay. Yeah. Thanks everyone. Okay. So tomorrow I will do at the same time. Okay. Thank you.